Okay, ladies and gentlemen, we are ready to work on section 2.4, which is about formulas and percents. There are really three focus for this video. The first one is we want to solve a formula for a variable. So we're going to solve for variables, but the whole formula is listed in variables. These are often called literal equations and is something very common that we do in algebra and other subjects. Then we're going to focus in on one particular formula, the percent formula, and learn how to use it and then use it in applied problems. Okay, let's get going. Some very common formulas are geometric formulas. For instance, you have the area of a circle is equal to pi r squared, or the circumference of a circle is equal to pi d. You could have the perimeter of a rectangle is equal to twice the length plus twice the width. The area of a triangle, let's say the area of a trapezoid is 1/2 base 1 plus base 2 times the height, etc., etc. There are lots of formulas. And so with these formulas, we can solve for the missing variables. For instance, suppose you're doing a problem with circumference and you know the circumference, but you want to find the diameter. Then what you can do is remake this formula into a formula that solves for the diameter. So pi is just a number, so we take c equals pi d, and we divide both sides by pi. Using the multiplication property of equality, the reciprocal of pi is 1 over pi. And then that gives us the circumference divided by pi is equal to the diameter of the circle. Okay? You could also solve for pi here, where you had the circumference divided by the diameter equals pi d divided by the diameter, and get the circumference divided by the diameter of a circle is equal to pi. And by the way, the ancients knew this, and this is how they discovered that pi was approximately 3.1614. They used this strategy to solve for it. Anyway, these can be more complicated. For instance, like the perimeter. Suppose we want to solve for the width, and so we take the perimeter equals twice the length plus twice the width, and then we subtract twice the length from both sides. So we get p minus 2l is equal to 2w, and then we multiply both sides by 1/2 or divide by 2. And so we get p minus 2l divided by 2 is equal to the width. Now, you could have done this in a slightly different way and ended up with the answer p divided by 2 minus l. And that would also be true. So the question is, how do you get this one? Just a question I want to ask you to think about. And what you would do is you would divide both sides by 2 first, getting p over 2 equals l plus w, and then subtract the l. So you could do that as well. All right, let's move on. These are called literal equations, and you're going to solve formulas for different variables as a part of this assignment. Oh, and I should mention, they're not always geometry. A formula could be any sort of formula. In fact, the formula we're going to use here in a moment is the amount of something is equal to the percent of whatever you start with. Or so, for instance, the amount you have left is the percent times whatever you start with, or the amount at the end. It just depends. But this is very common. We use this in finance and all kinds of things. All right, so this is the percent formula. So let's talk about that. So when we start to do percent story problems, there is a pattern to it, okay? We have what percent of blank is blank. And so if we look at the formula, what percent of B is A, all right? And this gets translated, the is equals, so is A, the of is multiply, so you take the percent of B, percent times B equals A. Now, and that's the formula we just gave. And so we're gonna look at some story problems, and our goal is to translate those story problems into this sentence. So let me give you a quick example. Number 29 in the assignment. Number 29 says, what number is 18% of 40? Okay, so we want to translate that to percent of number is number. And so what number is, that's what we're trying to find. This is the A. A is what percent of 40, all right? And so we can say A equals 18% of 40 multiplied by 40. Now, one of the things you have to know about percent problems is in order to do math, you have to change that percent to a decimal or a fraction. In this case, I changed it to a decimal, 0.18, okay? Now, remember 18% means 18 per 100, which means 18 hundredths, and then you can write that as the decimal, 0.18, all right? So what number is 18% of 40? 18% of 40 is going to be smaller, so if we take A and we take 0.18 times 40, we end up with this, 0, 32, 3, 7. We end up, whoops, put that decimal point in the wrong spot. We end up with 720 when we multiply this, but 2 decimal places. So 7.2 is 18% of 40, okay? Anything under 100% will usually be smaller, and a percent of is. Anything over 100% will be larger. All right, here's another one. 32% of what number is 51.2? Okay, so percent of is. So percent of a number. So this is 51.2. So our amount is percent of a number, all right? And so we know it's 32%, so 0.32 of what number, we don't know that, so that's our variable, is 51.2, that's the amount, all right? So we're trying to find 32% of some number that'll leave us 50. So this number B has to be bigger than that 51.2. So all we need to do then is go through and solve this problem. So we divide each side by 0.32. And then we calculate that. 51.2 divided by 0.32 equals B. and calculate that. I don't have a calculator handy, so, well, I can do it. I can do it on this. Let's do this. Let's go to the browser, and we'll do the Desmos Scientific Calculator, and there we go. And so now I will do 51.2 divided by 0.32. And that answer is 160. So if I make it a little bigger, you can see it's 160. So 160 is the number we were looking for. So 30% of 160 is about 50. That makes sense. It's about 1/3. All right? So that's the kind of process you want to go through. Now, at this point, then the rest of the problems are going to be an application type problem. Okay? And so we want to look at maybe a couple of those. All right? Let's look at number 65, all right, in your textbook. 65 says, suppose that the local sales tax rate is 6%, okay? And you buy a graphing calculator for $96, okay? The question then is, how much tax is due? And then the next question is what's the total cost of the calculator? So a very practical problem. This is very typical of what you might encounter. So a quick example. So we're going to buy a calculator for $96. So what we're saying is the tax rate of the cost of the item is the tax. So we're saying tax is tax rate of cost. And so this is what is the percent of is what? That's essentially what we're doing. Percent of some number is some number. So we're trying to think of that in terms of these new words. And so we're trying to find the tax. So the tax is 6%, 0.06 of 96. All right? And so our tax is going to equal whatever this multiplies out to. So 36, carry your 3 is 54.57, and you have 2 decimal points. So our tax is $5.76. All right? And then what's the total cost? Well, total cost is always the cost plus the tax in this case. So total cost. And so we need to think of this in a normal way. And so the cost was $96 plus $5.76. So the total cost is equal to $101.76. And so your practical applications are going to be like this. All right. Often you're going to have to find something, and then you're going to need to add or subtract that to something else. All right. It's very typical type application problems, and we may look at a couple others of these in class. All right. That's all I have for you. See you later. Enjoy. I hope you enjoyed these 2 videos.